Well, good morning again, ladies and gentlemen. It gives me great pleasure to introduce the second speaker of today at the DNA workshop, sponsored by Family Tree DNA and organised by ISOGG. In fact, it was organised largely by Debbie Kennett, who is a member of ISOGG, the International Society of Genealogy. And Debbie is an Honorary Research Associate in the Department of Genetics, Evolution and Environment at University College London. She is a member of ISOGG and co-founder of the ISOGG Wiki. She is the administrator of the Cruwys DNA Project, the Devon DNA Project, the mitochondrial DNA Haplogroup U4 Project, and has written 2 books on history tests, DNA and Social Networking in 2011, and the Surnames Handbook in 2012. A popular blog, Cruse News, was originally set up to publish findings from her own one-name study, but is now focused on keeping everyone up to date with all the latest developments from the world of genetic genealogy. So a better person to talk to us about understanding DNA testing, the pleasures and the pitfalls. Ladies and gentlemen, Debbie Kennett.
Thank you, Morris, and thank you everyone for coming here. I was worried there was not going to be anybody turning up because Tony Robinson is talking in the Celebrity Theatre, so I'm flattered to see there's a few people in the audience here today. Now I have got a PDF version of these slides available in my Dropbox account if you want to make a note of that, and then you can download that and refer to them. I'm going to cover some simple things and also some more complicated things, so there are some things you may want to come back and refer to. How many people here have taken an autosomal DNA test? Most of you, right, that's good, because I was rather hoping that's going to be the case when I prepared this talk. You never quite know who's going to turn up. But I will start by covering just some of the basics and just the sort of fundamentals of how autosomal DNA testing works. And then I'm going to go on and look at how you what you actually do with your results and some of the pitfalls that people do fall into. Okay, so when we use autosomal DNA testing, there are 2 main ways of using it. If you've got a particular hypothesis about a relationship, it's a very effective method for testing those hypotheses, whether or not 2 people are first cousins or second cousins, full siblings or half siblings. But I think most people are using it doing what we call the fishing trick method, where they're just taking a test and they just want to see what comes up amongst their matches. And how many of you have got brick walls in your family tree? There's a few hands who didn't go up. So who hasn't got a brick wall in their family tree? Oh, right, so we all have, yes. So, I mean, I think we're all hoping that we can use these tests eventually to break through on those lines where we're having problems. And it's just a nice way of connecting with genetic cousins. You also get admixture percentages with these tests, but that's not really the main reason for testing, and those results aren't particularly useful at the moment. One of the tests offers health and trait reports. I'm not really going to go into that. That will be another subject altogether. Now, we currently have a choice of 3 different testing companies. They all have their strengths and weaknesses. I won't go through the whole chart, but 23andMe were actually the first company to offer this test, but their test is the one that also gives you all the health and trait reports. But for genealogy purposes, that test is not really particularly useful, because you find a lot of the people, they're in the database because they wanted to know about their health, and they don't even bother signing up to the relative finding service. Family Tree DNA were the next company who actually entered the market, and they've been selling their Family Finder test for a lot longer than Ancestry, who only started selling in the UK in January 2015. But Ancestry have a sort of huge marketing power, so I think that is going to start to bring in lots and lots of people, and they're selling it at a low price at the show here. So again, it depends on which countries you're trying to find your matches. Family Tree DNA are actually the only ones who have a worldwide database. So if you've got relatives in Argentina or Thailand or South Africa, they're the only company where those people can get tested. AncestryDNA, they've launched in the US, so it was initially a very US-dominated database, but they launched there in 2012, but only launched in the UK in January 2015. But they are starting now to bring in other countries. Canada and Australia and New Zealand they launched there last year, and then just earlier on this year they launched in another 29 countries. But they're missing, crucially, some big countries like France, Germany, and Italy, whereas those you can get tested at 23andMe and Family Tree DNA. The databases vary from one company to another, but it depends on what you're looking for, because if you're trying to find a particular match, you're just fishing for a match, you just never know where that match is going to come from. So we normally say it's a good idea, if you're going on a sort of fishing expedition, to try and be in as many databases as possible. And especially if you've got, say, like an unknown parentage case, we've got people like foundlings, adoptees, donor-conceived people who are looking to try and connect with their biological parents. They really need to be in all the databases if possible. Yes, now the other point I wanted to make is that you get different features with different companies. Now, one of the limitations of the AncestryDNA test is you get lots of features, but you can only access those features if you're a subscriber. So they are selling the test, getting people in, but then if your subscription lapses, you'll then find you won't be able to access their DNA Circles features, you won't be able to access the full family trees of your matches. So that only works if you keep maintaining your subscription. You can still contact the matches, but you just can't access all the extra features. Whereas 23andMe and Family Tree DNA, once you've done the test, you just stay in the database and you can carry on accessing everything. Now, a lot of us like using a feature called a chromosome browser. You probably all, how many people have got chromosome browsers they're using? Only a few of you, right, okay. So that's one of the things that a lot of us actually like, to be able to see the visual representation of our results. And that is something you only get with Family Tree DNA and with 23andMe. And also access to the raw data for your matches, which again a lot of us like to use just to check that we think the relationship predictions are correct. Now, if you wanted to be in two different databases, the cheapest way of doing it is to test first with AncestryDNA and then do this autosomal DNA transfer programs. How many people have tested with AncestryDNA here? And how many people have tested with Family Tree DNA? And how many with 23andMe? Right, okay. So this worked with the old 23andMe kit, but it doesn't work with the new version. So you have to be on version 3 of 23andMe to do this. But if you've tested with Ancestry, you can transfer to Family Tree DNA. If you've tested at Family Tree DNA, you can't transfer to Ancestry, so you have to retest there. And this costs, it's $39, which is about £25. So that's the cheapest way of having your results in two different databases. I'm just going to go through the basics very quickly of how autosomal DNA works, because I think it's important just to get an understanding of the process. So the autosomal DNA test is looking at our autosomes, and we each have 23 pairs of chromosomes. We get one set of chromosomes from our mother, one set from our father, and of those chromosomes, 22 of them are autosomes, and one pair of the sex chromosomes. So if you're a female, you have an X chromosome from both of your parents, and if you're a male, you have an X chromosome from your mother, and you have the Y chromosome from your father. The important feature about the autosomes is that they do something called recombine. So they actually get shuffled up, and the DNA that you inherit from your parents is actually a patchwork of the DNA from all 4 of your great-grandparents. So this shows the process just on one chromosome, and we've got 3 children there, and they each get slightly different combinations of the DNA of both of their parents there. And it's all chopped up into little blocks, and they all match on different segments on different parts of the chromosome. And this is the chromosome browser. And this is a comparison. This is actually my mother and my son. And the orange segments, for those of you who haven't seen the chromosome browser, the orange segments are the bits of DNA where they match. So this is the feature that's a Family Tree DNA that I really like, because I just find it really interesting and educational to be able to see all these, how the DNA actually works, and to actually see this inheritance process. You miss out on all of that at AncestryDNA. So you can see here that my son's got one chromosome down here. He's inherited the entire chromosome, And then on this one, he doesn't actually have any of that chromosome at all. And then when we go out to third cousins, there's only just a few segments that they share in common. And once you get out to the fourth or fifth cousin level, you probably will only have one segment that you will share with a cousin. And this is a comparison between my son and his two paternal grandparents. And you can see there this process of inheritance, so we can actually reconstruct his whole paternal chromosome, and you can see how the two bits that he gets from his grandmother and his grandfather, they sort of lock together like teeth there, and you can actually see where the segments of DNA have got broken up. So with his matches, I can actually assign a match to a particular, I can actually say whether it comes from his grandmother or his grandfather on that paternal side, depending on which segment of DNA he matches on. We've got a page in the ISOGG Wiki on autosomal DNA statistics. This is an important page everyone needs to refer to, and we've got far more statistics there, but these are the expected amounts of DNA that you would share in common with your cousins. And with your grandparents, everyone shares roughly 25%. But what we find is that this is something when we start to look at all these statistics, and with the chromosome browser, we find there's huge variation. So you may have 19% of your DNA from one of your grandparents, and you might have 28%, 29% from another grandparent. And that effect becomes much more pronounced as we go further back in time. And once you get out to the sixth cousin level, you only have a small amount of DNA that you share with your cousins. And once you get out to that level as well, you will have relations where, although you've got the genealogical relationship, you don't actually share any DNA at all. This is my family tree. It's important to remember we all have two different types of family tree. We have our genealogical tree, all those ancestors we can trace on our paper trail records, and you can see I've actually got quite a lot of brick walls in my tree. I've got a great grandfather I've been unable to identify. He seems to have arrived in London from some sort of alien planet. I don't know where he arrived from. There's no birth registration. He's missing from all the crucial censuses, and I think he's in disguise under a different surname. And I think he might be a Williams, which doesn't help. So if I wanted to look for Williams, I'd have to buy I don't know how many different birth certificates for John Williams, born in London. So I've got quite a few brick walls there that I'm hoping eventually autosomal DNA is going to provide the answer on. But the important point here is that once you get out to these outer rings of your family tree, though that's the point where your ancestors start actually to drop off your genetic tree, and you just simply do not inherit any DNA from them. So that's why it's important to test with autosomal DNA, to test as many people as possible. So I tested my parents, and so by doing that I actually go back one further generation, so that will pick up some of those missing ancestors, if you like. If you can't test parents, you can test siblings, and siblings will actually pick up, they will have a different representation of DNA, because you both get a different combination of DNA from your parents. So it may be, if I was to test my sister, she might have the bits of DNA that I'm missing. And I obviously don't know which bits of DNA I'm missing, but that's just a sort of theoretical representation. Now, if you're looking to confirm relationships with matches, it's important to bear these statistics in mind. If it's any match up to second cousin, you should be matching. If you don't match your first cousin, your second cousin, then the two of you need to put your heads together, and there's something funny been going on in one of your family trees, and you've got what we call an NPE, non-paternal event, or not the parent expected. But once you get out to the third cousin level, you will find some third cousins with whom you just do not share any DNA. If you think back to the grandparents, if you've only inherited a small amount of DNA from one of your grandparents, and then that drops off in the next generation, you will have some where you don't actually inherit that DNA. And AncestryDNA do a specialist technique called phasing, which I'll cover a bit later, and with that technique they claim a better detection rate for the third cousins and fourth cousins. But you can see once you get out to the 6th and 7th cousin level, you've actually got a very low chance of actually matching with those cousins. So maybe your family tree is perfectly correct, but it just won't show up in the DNA. Now, the other side of the coin, of course, is that we actually have huge numbers of cousins. This is a study that some researchers did back in 2012, and they tried to estimate the number of cousins that everyone has. And they also tried to estimate the expected number of detectable cousins from DNA testing. So this is just an average, and obviously some people will have much larger families and some will have much smaller families. They only have 3 first cousins. But you can see once you get out to the once you get out to the 5th cousin level, you actually have huge, quite large numbers. And then once you get out to the 8th and 9th cousin level, you have huge numbers. Now the mathematicians like to make things difficult, and they write things in cryptic numbers. I had to look up what 10 to the power of 6 was, and it's actually 1 million. Okay, so it's just, the numbers just get phenomenal out there. But you can see how you've got far more of these distant cousins than you have of the close cousins. So when anyone takes an autosomal DNA test, you will find that you get lots and lots of matches with distant cousins and not so many matches in the close cousins. Now when you're doing this test, it's always, as I said before, it's always best to test the oldest generation first, and while you still have the chance, because once they've gone, that DNA record is lost forever. So even if you're not ready to start testing, it's still a good idea to get those elderly relatives to test now while you have the chance. So if you can, test your parents. Some people are even lucky to have grandparents who can test. And if you don't have parents who can test your aunts, your uncles. And if you've got a sibling, test your sibling. We've got some people who are testing lots of siblings, trying to reconstruct the DNA of their grandparents. And it's also helpful with these tests to try and test other close relations like 1st to 3rd cousins. So if you have a match with someone and you also share that match with your 2nd cousin, then you will know that that will narrow down the possibilities of the common ancestor, and you'll be able to work out which line it's on. So I've just put up here the number of matches that I have in the different databases. The numbers vary considerably. 23andMe, my matches are actually going down. They're in the middle of transitioning to a new platform, and they've been taking my matches away, but they should eventually go back up again. But when I look at my matches at 23andMe, almost half of them are actually anonymous, and I can't even contact them, so that's not really very helpful. At Ancestry, I have over 3,400 matches, but again, most of them are very, very distant cousins, and at Family Tree DNA, I have about 500 odd matches. But at the moment, it's still quite early days in the UK for autosomal DNA testing, and I've so far only been able to confirm, I've confirmed 2 matches at Ancestry, one with a 3rd cousin, one with a 3rd cousin once removed, and I also confirmed a 4th cousin at Family Tree DNA, and the other 2 there, I actually got them to transfer from Ancestry so that I could look at their results in the Family Finder database. So it is common, you will find lots and lots of distant cousins, but don't worry if you can't find the connection. We all have the same problem, and in most cases you'll be on a wild goose chase trying to find those connections. There are some people who end up with huge numbers of matches. Does anyone have Jewish ancestry here? Right. Have you tested? Oh, sorry, I can't catch you later, but people with Jewish ancestry end up with huge numbers of matches. I have a British Jewish friend, and she's got literally thousands of matches. I think she's got something like 10,000 matches with Ancestry and about 4,000 at Family Tree DNA. But they're an endogamous population, and they married within their community, so what they predict as a 2nd cousin with them is actually quite often a 4th cousin. But that makes it much more complicated to work out the relationships. Now, just some important terms. When we look at a chromosome browser, it's important to remember that what we're seeing there are what we call half-identical regions. Because chromosomes, if you remember, come in pairs. You get 1 chromosome from your mother, 1 from your father. You're only seeing a match on 1 chromosome here, but at the moment the companies aren't clever enough to be able to tell us whether that segment of DNA is a match on your paternal side or your maternal side. And the other term that I just wanted to mention, you will come across something called a centimorgan, and that is just the unit that is used to measure the size of the segment. So you don't have to worry what it means, it's just a term that you will come across. These are my matches at AncestryDNA. I have 27 fourth cousin matches in total there, and I have the rest of them are all the distant matches. So at Ancestry, I would say it's really only worth bothering with those very close matches unless you've got a surname in the more distant matches that happens to show up. They do have a nice feature called shared ancestor hints. How many people have got shared ancestor hints at Ancestry? How many have you got? Really? Oh right, you're doing much better than me. Right, I've only got one. But when it works really well, because they actually identify the common ancestor for you, so they do all the hard work. And in this case, this is how I identified a third cousin, and sorry, I'm jumping ahead of myself here. Yes, this actually shows the matches, and this is one of the cousins that I was able to identify with a shaky leaf hint there. And when we go through to the tree, it actually identifies you have to have both trees in the system, and then it identifies the common ancestral couple and even shows you the path, how you're related. So that is really, really neat, but I found it difficult to actually get the shaky leaf hints, and even when with another match where we've identified the connection, we've even tried to put more information in the trees, and the shaky leaf hints still won't even show up. So I think they probably need to do something to improve their algorithms. Now, the other thing you can see, they've hidden this feature away. If you are interested in looking at the centimorgan counts, you can actually access this information there. So it's hidden away, but it's under that little question mark there. So there are some people who like keeping spreadsheets of their matches and looking at the amount of DNA that they share in common. Another useful feature at Ancestry is that you can look at the matches that you share in common. So having identified a third cousin, I can then look at the matches that we share in common. And in this case, I've got two other fourth cousins. But the frustrating part is, when you look at the family tree, they haven't put anything up at all. And I've written to them, and so far they haven't replied. So I'm hoping that one day we will get somewhere with those. But sometimes I find it's just a question of patience. Sometimes I've sent messages out and I get a response like a year or 2 years later. So I think people sometimes they take these tests and then forget about them and then suddenly rediscover them later on. Ancestry also have a feature called DNA Circles. So those of you who've tested Ancestry, how many of you have got DNA Circles at the moment? Oh, that's good then, right. I still don't have any, but it is actually a very nice feature when it works. I've just shown their example of Kenny Freestone, but there are a number of conditions that you have to satisfy to get one of these DNA circles. So first of all, you have to have that all-important Ancestry subscription, and you also have to have what they call a public family tree, which is actually restricted to Ancestry subscribers, and you need 3 people in the circle, and they must not be closer than second cousins. So if you've tested your parents or your aunts or uncles, they're treated as one family unit. They don't count for the circles. And the circles also only go back for 7 generations, and that's starting with you. So if you're looking at matches in the 1700s, those won't show up in the DNA circles. Now, family tree DNA, their system is slightly different. This is my match page at Family Tree DNA, and here we also have the Chromosome browser, and we have a number of extra tools at Family Tree DNA. At Family Tree DNA, it's very important to make sure you can upload a family tree, but even if you don't do that, make sure you enter your surnames that you're researching, and it's also helpful to enter the location. And I'll explain why that's important a bit later. The other feature at Family Tree DNA that we get are the projects. Now, a lot of the projects started off as Y chromosome DNA projects. A lot of us are studying surnames, but there are also a lot of projects that will accept autosomal DNA results. So I run a project for Devon, And I have Y chromosome results, mitochondrial DNA results, and also family finder results in my Devon project. There are a number of geographical projects. There are projects for Ireland, Scotland and Wales. There are a number of regional projects. There's an Oxfordshire project, and there are all sorts of specialist projects as well. There are even projects as Romneys, Jewish, all sorts of Jewish projects as well. And the advantage of being in a project is that you can search for matches within a project, and you can do that. It's this bit here where it says Advanced Matches, and that takes you through to this menu here. So I can then do comparisons, and I can see who is matching me within my Devon project, who's matching me within my Surname project. So that's a good way of filtering those matches. If you've got lots and lots of matches, at least it's focusing on the active people who share ancestry from the same location. There aren't enough projects for all the different English counties at the moment, but the ones that are active, it's worth joining. And the other feature with family tree DNA is you can actually combine the Y chromosome testing and the mitochondrial DNA testing, and that is helpful to eliminate matches on those lines, or to determine they actually have a match on that same Y chromosome or mitochondrial DNA line. So that's that bit there. Family tree DNA, you can download your list of matches, and you have real email addresses, which is more helpful than having a messaging system on Ancestry where you just don't know if your message has got through. So you get real email addresses, and I find this is the easiest way to sort through the matches. And I actually use the email addresses to try and filter the matches, because you can actually work out where someone's from with the email addresses. So I can pick out BT Internet email addresses, and New Zealand email addresses, and Australian email addresses, because I want to find my matches with people in the UK, and I know I've got people in Australia and New Zealand that I should be matching, whereas I don't have any relations in America. So all the American matches, if I match them, it's going to be back in the 1600s, where there's no chance of even finding a connection. And also, this is an easy way of searching through the surnames as well, to try and look at the locations. So with the family finder matches, the best tactic I find is to focus first of all on the surnames, and especially the rare surnames, because those are the ones where you're likely to have the most success. And also look for the shared geographical locations. If people have entered the geographical locations, they haven't always. And the country-specific email addresses. So, I mean, if someone's like a fourth cousin and they've got a UK email address, I'm much more inclined to contact them than if they've got a Comcast address in America, because at least I know I've got more chance of working out the relationship. And it's best to concentrate again on the closest matches, the ones that are predicted to be fourth cousins or closer, because there is a problem with false positive matches, especially when you get out to the fifth and distant cousin level. And at family tree DNA, you need to focus on the matches with the longest shared segment of DNA. So you can start at perhaps 10 centimorgans or 15 centimorgans. If you start dropping down into the smaller segments, you end up with lots of false matches, and you could end up going on a completely false trail and thinking it's a match when it's not a real match at all. And in particular, you need to ignore any of the very small segments that are under about 5 cm. Family tree DNA do actually show you those segments, but they are just noise. None of the technology at the moment can actually detect those very small segments, because we're not looking at the whole genome, we're only looking at certain SNPs scattered across the genome. So we just haven't got that level of accuracy at the moment. Now, when the tests at family tree DNA, sometimes it's actually quite easy to determine the match, and I was just going to share one of my success stories with family tree DNA. And this is why you need to put your surnames in, because when you have a matching surname, it shows up in bold on the list there. And Cruse, that you can see there showing up in bold, that is actually my maiden name. And so I was quite excited when this match showed up there, and all their ancestry was in Canada. And so the only way they could possibly be related was through this Cruse surname. And I actually had identified in my family tree the brother of my great-great-great-grandfather, who we thought might have gone to Prince Edward Island, and that was just done by really circumstantial evidence, because he just disappeared from the census in 1841. There was no death record. And then I'd found this Cruse family in the 1881 Canadian census, but I just couldn't find any records tying them all together. And I even went as far as getting a marriage certificate from the archives in Charlottetown in Prince Edward Island, but on the marriage certificate there from Canada, it didn't show the names of the fathers of the bride and groom. And there's just physically no record that will actually link that Canadian family with the Devon family. But now we actually have that confirmation of that link through the DNA match. The DNA can be really, really powerful once it starts to work and once you start to make these connections. And we're going to see that happen more and more as the databases grow in size. So again, I like to look at the matches in the chromosome browser. So this is my dad compared with his Canadian cousin, and you can see he's just got 3 segments of DNA that he shares in common, and their relationship is third cousins once removed. And then when I watch the DNA go down through the generations, that's the DNA relationship with me, and you can see I've only got 1 segment that I share with him. So immediately from one generation to another, 2 of those segments have just been lost. So that bit of DNA is gone forever. That bit of Cruse DNA that my dad's got, I just don't have. I've got that bit of DNA from my mum instead. And then I also went on and tested my son, and he actually had that bit of DNA passed on from me, but it could be another generation and that bit of DNA could be gone. I was going to test another son, I haven't got round to doing that yet, to see if he has that same segment. I find it fascinating to be able to actually see this inheritance process in action, and just to understand how chromosomes work, and because I didn't even do a science O level at school, so it's my education is starting now. Now, if you are, this is for the really dedicated people. We have someone in our community, Tim Jansen, who has probably done more autosomal DNA testing than anyone else on the planet. And he's tested over 100 of his close relatives, and he's shared this slide with me. But what he's been able to do is to map out a large portion of his chromosomes. So if you were to match Tim Jansen, he would be able to tell you, oh well, okay, well if you match on chromosome 12 on this blue bit, okay, well we must be related through my ancestor Paul Youngman. Then if you match him on another chromosome down here, maybe that orange bit, okay, well we must be related through my ancestor Harriet Lawrence. So, and one day this will probably all be automated, and the future is perhaps in 20 years you may even be able to take a DNA test and the companies will actually predict who you match, and they will say, right, okay, you match on this segment and this is your ancestor. We're not there yet, but I think that will be the future. At Family Tree DNA, they also have an in common with menu. It's a bit difficult to find, but there is this little bit at the top there, and you can toggle backwards and forwards, and once you've got that menu opened up, you then see these bits here. So then you can look at your matches in common, you can do a comparison in the chromosome browser, you can look at the longest block of DNA, so this is very useful. So you can actually see all the matches you share in common, and you can put them into the chromosome browser. Now I wanted to say something about triangulation. It may be something not everyone is doing. This is slightly more advanced stuff, but what people are finding is they're seeing patterns in the data, and quite often you see lots of people who appear as though they all stack up on the same segment there. And it's very tempting to think, okay, well if we all match on that same segment, we must all share a common ancestor. But unfortunately it's not as simple as that. Because if you all match on the same segment, it usually means that it's a sign of more distant shared ancestry. Because of this inheritance process, once you get out to say the 5th or 6th cousin level, you only have one segment that you share in common. So if you share a match with a 5th cousin, you might match one 5th cousin on one segment, but you're going to match another cousin who's not going to match on that same segment. They've probably got a different bit of DNA. So the only way that you can actually get circumstances where lots of distant cousin matches on the same segment is if it's that population level. But this is actually an area of great controversy at the moment, and I actually did a blog post. If you want to read about this, you can read my 2 blog posts that are linked on the triangulation page there. But this is, in fact, in some ways it's exciting about autosomal DNA because we're still learning as we go along. And so we're still trying to get to the bottom of some of these issues. So one of the issues is the lack of phasing, which I'm going to mention briefly. So that may possibly will produce some false positive matches. And again, we think that some of these groups are signals of distant shared ancestry. And the other problem, of course, is as you go further back in time, once you have, say, someone like a 6th cousin, he may be your 6th cousin, but he might also be your 8th cousin, and he's probably also your 10th cousin. So you find that everyone's related to everyone else through lots of different ancestral pathways. So this is something we're still investigating, but I would say for the moment the jury is still out. It's an effective technique for close relations, but it's more suspect than distant relations. But you will find a lot of people advocating this methodology. So that's just, don't take everything at face value. Now, I just wanted to mention briefly about phasing. This is where it gets a little bit more technical, but this is something that is important to keep in mind. Some of your matches will be false positives. We're not at the stage where we can sequence the whole genome at the moment, and we have this problem of lack of phasing, which I will explain in a minute, but once you get down to the small segments, we have some that turn out to be false positives because of the lack of phasing. And the larger ones are usually okay, but once you get down to these smaller segments, well, the 7 centimorphin ones, there's a very high false positive rate. So that's why we try and encourage people not to use those small segments. So phasing is this process of sorting out all the A's, C's, T's and G's into the paternal and maternal chromosomes. So if you have a look at your raw data, you will see 2 columns, and you will have like TTGA, but it's not sorted so that all the letters on one side are from your mum and all the letters on the other side are from your dad. So there are ways of doing that process, but it may be when the phasing is done, you end up with things in slightly different places. But you can imagine when the algorithms are working through, what they're doing is zigzagging backwards and forwards from both columns, trying to find a match with someone else who also has letters in both columns, and it's much easier to find matches when you've got 4 columns to choose from than when you've just got 2 columns to choose from. So you can think of it rather like playing a game of poker. Okay? So who plays poker? No one? I'm the only poker player here, right, okay. So in poker, if you have a flush, you have 5 cards and they're all in the same suit. That's fairly difficult to get, but it's much easier to get if you only have 1 pack of cards. It's actually quite difficult to get, but if you have 2 packs of cards like that, you will find it's much easier to get 5 cards coming out in a row. So that's rather like the phasing. It's a process of where we're looking at 2 packs of cards instead of 1 pack. So that process makes it much easier to find matches, but some of those matches are false positives. I just wanted to end by talking a little bit about some third-party tools and also the admixture percentages. You shouldn't take these too seriously because they're not that accurate at the moment. A lot of it depends on the reference populations that are used, and you will also find if you test with different companies you will get different results. I come out at 57% British and Irish with 23andMe. I come out at Ancestry, I'm only 21% British, and I've got this really high percentage of Irish, which I don't actually have. And at Family Tree DNA, again, I come out at something like 57% British. I find a lot of Americans have very high levels of British and Irish, so I quite often see American people with like 95% British and Irish, and British people end up with quite low percentages, and sometimes not even any British, even though all their ancestry is from Britain. So these you can't really take too seriously, except at the continental level. If you come up with something that's Asian or African, that's a real signal of something. And also Jewish ancestry, if you come up with Ashkenazi Jewish ancestry, that is a real signal of something. And Finnish ancestry, the Finnish population was very isolated, so if you come up with, and they've sort of they actually show up very strongly as a distinct population. But all of these tests are being improved. Family Tree DNA and Ancestry are both rolling out new versions of these, and we're already on the third version. This is the second version with all three companies. So once you've done the test, you will keep getting improvements to the algorithms as we progress. There are some very useful third-party tools that you can use. One of the most useful ones is GEDmatch, which is a free site provided by genetic genealogists. The main site is free. That there is a second tier service that you can use where you have to pay a small fee. And this is very useful if you've tested at Family Tree DNA and you discover one of your cousins has tested at 23andMe, rather than both of you having to do new tests, you can compare your results on GEDmatch. And they've got something like 110,000 people in there back in November. I don't know what the current number is. So when you look at the website, there's not much to look at all. It looks like that. But once you've registered to sign up, you can then access all these extra features here. And they've got all sorts of fancy tools that you can use. You can see if your parents are related. And if you've tested both of your parents, you can actually do this process of phasing there. And they will actually do that for you automatically. And there's also various admixture results that you can use as well. So that's a very useful free service that you can use. That is that's one of the admixture tools that we have. And this is all provided free. So what they do is collect reference populations from all the academic papers that are published, and that you compare your results with those. The other nice tool is something called DNA GEDcom, and there's a very useful tool called the Autosomal DNA segment Analyser on there, which allows you to look at your matches in a visual representation. And there's something called GenomeMate. I haven't actually used GenomeMate, but some other people do use that. There's a list in the ISOGG Wiki of all the different autosomal DNA tools that you can use there. And this is the Autosomal DNA segment Analyser. This is probably, again, for more advanced users, but this shows you chromosome by chromosome. It takes all your in common with matches and does this process of triangulation. So the triangulated segments, when they're small segments, are really ones that you're best avoiding. So it helps you to focus on the ones that are likely to be more useful. And another one that has just started up is DNA Land, and this is run by a couple of academics in New York. And by adding your results to this database, you can actually contribute to science, because they're using your results in their scientific research. And they are providing some features as well. They are providing a relative matching service. I don't currently have any matches there. It's only been going for a few months. But one thing I like about their matching process is they do it in a slightly different way to everyone else. And they report on recent and ancient segments of DNA. So you will get some chromosomes where you will have part of it is, say you've got a 10 cm chromosome segment, and it may be that half of it is recent and the other half is an ancient segment that everyone in a population will share. So this is potentially one useful way of checking some of your matches and just getting an alternative reading of your matches to see if you've got these ancient segments of DNA showing up. And they do this on the frequencies of the markers in those segments. Just to close, I just wanted to mention some of the useful resources. If you're on Facebook, we've got a very nice little UK Facebook group, DNA Help for Genealogy UK, which is now getting very active. There seem to be lots and lots of people in the UK who are getting tested. So we've got two very helpful admins, Donna and Seth, who are always there answering questions. So any question, however silly it is, don't be afraid to ask, and they would be happy to help. And within ISOGG, we have lots and lots of resources. At ISOGG, all free resources. You can join ISOGG for free. We have a website, we have a wiki, we have a very active Facebook group, and there are a whole range of different mailing lists. And we've actually got a really nice genetic genealogy community. We've all been learning as we go along, and there are always people you can help. Sometimes it's a question of working out who on a list is giving the right answer. You gradually get to know. Some people don't know what they're talking about and others do, and you soon start to recognise whose advice you should be taking. And then obviously there are lots of blogs as well, and I've got my own blog on that list. Okay, so I think that's covered everything. I hope I haven't confused everyone even more.
Great, thanks very much, Devon. So, questions for Debbie? We have a question over here, a question over here, a question over here. Okay, let's move on. First.
mtDNA. Do I upload both, all of them to GEDmatch, or?
You only need one kit on GEDmatch. It gets confusing if you upload 3 kits. And if you've only tested recently with 23andMe, I would upload an ancestry or family tree DNA kit, because they have more markers, so you'll get better matching with those kits.
Do you know why it is that the different companies end up with a very different genetic mixture? Why it's not?
Well, they all have different reference populations that they use, and also they're looking at different time frames. What they are starting to do now, 23andMe and Ancestry, using their own customer base, and so if they've got with Ancestry's latest update, I think they've got something like 3,000 people actually in their customer base that they're using as the reference sample. So they've got the family tree, so people with, say, all 4 grandparents born in England or Wales. 23andMe does the same. So it really depends on which reference populations they use. They're all using the same program to generate the matches, but some of them might include more of one population than another. And yeah, so.
We have a question there.
Yes, Debbie. And GEDmatch, differently nested. The reason I ask that is I have a particular cluster, second to fourth cluster on mtDNA. It's a 5th to 8th cluster. It's a 3rd to 6th cluster directly on 23andMe. Now on GEDmatch, it's about 5 generations back from ancestry, which is say 3rd to 4th cluster. So I have this range from 2nd to 8th cluster.
Oh, that's interesting. Well, I think that is just, in some ways, it's a limitation of the DNA. I would say that the AncestryDNA matches are the most reliable, simply because they do phasing. And it's that is something that probably will come eventually with the other companies. But the phasing is the thing that eliminates the false matches and enables us to make more accurate predictions. But there is anyway this wide variation in relationships. So it's very difficult once you get beyond about the second cousin level to make an accurate estimate. And there is a huge possible range. So it could be a 3rd cousin, it could be a 10th cousin. They just try and make the best possible predictions. And then you've also got complications with the people that you match. They may have cousin marriages in their family tree, which make the relationships look closer.
Hi, I'm just considering which of the family tree or ancestry tests to take. I just wondered if you could tell us in summary, if you take the ancestry one and transport the findings to family tree, what functionality do you lose on family tree? That's part 1. If you take the ancestry test and then map to subscription, what functionality do you lose on ancestry?
Right, if you do the AncestryDNA test, all you're doing is downloading your raw data. So actually doing the transfer, you're not losing any functionality from the AncestryDNA test at all. But once you go into family tree DNA, you have full functionality from the start once you've paid your transfer fee. But at Ancestry, once your subscription has lapsed, you do lose a lot of functionality. You can contact your matches, you can see a family tree, but it will only have names on. What you can't do is you can't click through and see the full tree and see the dates and the locations. And you also don't get the DNA circles and you don't, I believe you don't get the shaky leaf hints either. Or if you get, no, I think you may see, I think you will see the shaky leaf hints, but you won't be able to do as I did and click through and see what they think the relationship is.
So, summing that up then, if I did the ancestry test and transported the findings, paying the extra £25,
Yeah.
I'd get full range of things like family tree DNA.
Yeah. Yeah.
Are they going to corner the market?
Who?
Ancestry, if they're a bit cheaper.
Well, in actual fact, no. At the full price, if I go back to my first slide, oops, no. Sorry, let's put this down. Oh, it's Morris's Mac. It's all different to my slideshow. Okay, there we go. It's here.
Let's go
from
back
start. If I go back to my beginning slide, okay. Right, so the normal prices, Ancestry, they sell their test in America at $99. In the UK, they sell it for £99. But they also charge you £20 postage. So if you want to buy an Ancestry DNA test at the full price, it actually works out at £119. But they do have, so they've got a very good price at the show, and they do have special offers throughout the year. So I mean, it may be that price will eventually come down. Family Tree DNA, they sell their test in dollars, so it very much depends on the exchange rate. The exchange rate is not so good for us at the moment, so that works out at about, including the postage, is about £77. So I tended to use Family Tree DNA simply because it's been cheaper to get extra people tested there, but I just have myself at Ancestry. Although if it's £59, you can get more people into Ancestry. So it really depends on what your objectives are. And I also like all the tools at Family Tree DNA, and I like to be able to do, use the Chromosome browser and everything.
Debbie, what would be the minimum subscription that you have to take out with Ancestry in order to get access to all those features?
It would be the basic UK subscription, which I think is it £108 or something?
Yeah.
Yeah.
So if you're going to be doing your Ancestry for 10 years, that's going to cost you £1,000.
Yes. Yeah.
So that's just one thing to keep in mind. The other thing I think that the other advantage of Family Tree DNA is that they will store your sample for 25 years.
Yes, I should have said that, yes.
So if you do want to do additional testing on that sample, it will be there for 25 years for you to do those additional tests. Very useful if you're a man, for example, and you want to do Y-DNA testing and then further SNP testing on your Y-DNA. If you're a woman, of course, you can also do mitochondrial DNA testing, which of course is only done by Family Tree DNA. 23andMe will give you the basics of your Y-DNA haplogroup
Yes.
and your mitochondrial DNA haplogroup, but you really only get the full test at Family Tree DNA. Any other questions? Yeah, we have a question here.
So, my partner, when I took the statement before, I could do, so I did the autosomal, so I could do the Y-DNA, and also if there's any kind of improvement in the future, will that automatically get done? Will that data still stored there, and if any improvements that either Ancestry or mtDNA do in the future, will that get done for this test as well?
Well, this test will be with Family Tree DNA, so the sample. Oh, you've done both. Tested with Ancestry and then transferred to Family Tree DNA. Okay, well, you tested with Ancestry. The sample is going to be Ancestry. Now, Ancestry.
They do store the samples, but whether or not they let you have the sample to do a Y-DNA test with Family Tree DNA is another matter altogether.
Something you could ask the Ancestry standard.
Whether that might look better as well, we could do Y-DNA.
Did he do the Y-DNA at Family Tree DNA? So he hasn't got a sample at Family Tree DNA? Right. Yeah. So you can't order further tests for Family Tree DNA from that kit then, no, because they won't have the DNA.
Other questions?
Question here. You go to Ancestry, so you have the basic information. Does that store and use that basic information even though they don't measure themselves?
No, because when you download the raw data, you get unphased data. So they do the phasing in their sort of matching algorithms, but you don't actually have access to the phased results. So you're back to square one again once you put it on GEDmatch or you put it on Family Tree DNA.
GEDmatch you can actually face with just one parent. So you don't need to have both parents tested. You can just use one parent and yourself to actually get your phase. Any other questions? Okey-dokey. Well, listen, we've had a wonderful discussion, a wonderful presentation, so please give a big warm thank you to Devon.